Just a quick reminder of some of the basics. We're asked to write 87,000 in standard form. So we've always got to start with a number between 1 and 10. So we know we want it to be 8.7. At the moment, we've got this. Careful to put the decimal point in. We know it's going to be times 10. And so having asserted that, simply see how many place values you would need to move. 1, 2, 3, 4. If I moved 4 place values, I'd get 8.7. Now this is a big number, so one way of looking at it is we know it's going to be a positive. Similarly here, we know in standard form we need a number between 1 and 10, and in this case we've got to include any digit, so we've got to go all the way down to 3. Again, with standard form, we certainly know it's going to be in this format, and we're going to compare it to the number here. So it's 0.000103. And again, how many place values would we need to move to get to the form we've got? 1, 2, 3. We'd need 4 place values. Now this is a small number, so it's going to be to the minus 4. Of course, alternatively, you will just simply know which direction to go to, either increase or decrease, or move to the left or the right. But a very quick, succinct way is just to ask yourself, if it's a small number, it's always going to be a minus, a large number, be a positive. Might be asked to go the other way, given a number in standard form, asked to write it as an ordinary number. Again, I'll start off with my number, and I'm simply going to look at this value here, and this is telling me that I need to move 3 place values, and again it's a positive, so I know I'm going to end up with a bigger number. So what I'm going to do is just a sort of a bit of a cheat really. I'm going to add a few zeros here just to make life easy for myself. I'm going to say I need to use 3 place value, move 3 place values. I need a bigger number, so it's got to be, I can view it like this: 1, 2, 3. And so that's the number that I would end up with, and I can just write this out as 6,780 if you like. In time, you may come to recognize that anything to the power 3 is thousands, to the power 6 is millions, to the power 9 is billions. And of course you can quickly home in on the actual size of these numbers. Here we have, we're asked to write this as an ordinary number. Again, I immediately notice it's to the minus 5. I know it's going to be a small number. I'm going to sort of, what I would describe as sort of load up the zeros. And I can see I'm going to move 5 place values. So again, a technique: 1, 2, 3, 4, 5. And there we have it. At a first glance you might look at this and think it is in standard form. It isn't, because this is strictly got to be a number between 1 and 10. Now what I'm about to describe here is a very important technique. What we've got is 0.9. I'll write this down here just for emphasis. This is the value that we have. 0.9 times 10 to the minus 2. I'm being asked to write it in standard form. Now what you end up with has got to be exactly the same number, exactly the same quantity, if you like. I'm just writing it in a different form. Now to get this in standard form, I'm going to multiply this by 10. In other words, I'm going to move it 1 place value, and you can see I've made this bigger by moving it that 1 place value. Now for this to be the same number, if I've made this bigger, then it follows I must make this smaller. And you can look at it either way. I've made it 10 times bigger, so this must be 10 times smaller, or I've moved this one place value, and so I must move this one place value. But it's always got to be the opposite. So this has been made bigger, so this is going to have to be made smaller, and you should know that I'm going to make it more negative to make it smaller, so it'll become -3. This is a very important skill that you'll use, and you've got to, as long as you understand that, I'm not changing the actual quantity, it's just how it's written. So, and that's why when one side goes up, the other side must go down, and vice versa. Similarly here, this isn't in standard form because it's not between 1 and 10, so I'll make it 10 times smaller. And in just the same way, because I've made this smaller, I now need to make this bigger, and it's one place value. So I'll increase the 4 to a 5. Think of standard form in the way that you think of fractions. Multiplying and dividing fractions is actually easier than adding and subtracting fractions, and so is the case here. Think of it this way. It's multiplication, and in multiplication you can change the order. 5 times 4 times 1 is the same as 1 times 4 times 5. The order doesn't matter. So I'm going to group the numbers together and group the powers of 10 together. And then I'm going to just simply multiply the numbers as I would do, and then exploit the rule of indices. 10 to the 2 times 10 to the 3, we know we add the indices, and that gives us our number quickly. Not quite finished because this isn't in standard form. I need to make this 10 times smaller, and consequently this 10 times bigger. And we're done. Division. I'm going to do it this way. Five divided by 2 is 2.5, and then again using the rules of indices, 10 to the 2 divided by 10 to the 3, we subtract when we are dividing, and so we end up with that value there. And this is in standard form, we don't need to make any modifications. Just like with fractions, adding and subtracting is a little bit more tedious. I know that some of you like to change these to ordinary numbers and then add and subtract, and indeed I think some of you like attempt to change it to ordinary numbers and then multiply and divide, but certainly that can become unwieldy. The whole point of us using standard form is that these numbers aren't unwieldy. So like fractions, if I was to ask you to add a fifth and a sixth, not straightforward, because they aren't the same denominator. However, if I was to ask you what is 1/7 plus 3/7, you would very quickly, hopefully, be able to tell me that is 4/7. And the trick is here we're adding like things, not dissimilar to algebra where we add like terms. So these aren't like terms. We've got 10 to the 2, 3 lots of 10 to the 2, and 9 lots, or if you want to think of it of that as 10 to the 3. So we want to make them both the same. Doesn't really matter as such whether you decide to make them both as the 3 or both as the 2, but since 3 is the larger value, I'll stick with the 3. So I need to make this, change this, certainly to, oops, thinking ahead, change this to this, and because I've made that 10 times bigger, I need to make this 10 times smaller. And to make it 10 times smaller, as we know with our denary system, the place value system, we just move it one place. So there we have it. Remember, this has got to be the same actual value, that's why we're balancing out. And then I'm going to add to that 9 times 10 to the 3, and you can just see how easy it is. If I've got 9 times 10 to the 3, add 0.3 times 10 to the 3, well, I've got 9.3 times 10 to the 3. Simple. Now, they may weave in, if this is a non-calculator paper, you know, obviously this is, they could pick, you know, 2.4 and 3.6 to give you a bit of a workout on your pen and paper arithmetic as well, but the method is no different. And the same here. I've got to make them like for like. So I'm going to make them both the larger term, and actually, as we know, the larger term is going to be to the minus 2. So I'll keep that as it is. What would this become? Well, I want now it's important when we're working with the negative signs that you don't fall into the trap of just it's getting mixed up, which is how we make something large and how we make something smaller and into the realms of what's more negative, etc. So, but if I move from 10 to the minus 3 to 10 to the minus 2, I've made this larger because it's less negative. And if I've made this side larger, I need to make this side smaller. There we have it. Be clear on this. So now I can put my other side in. And again, we can just see how simple this is because we're subtracting, you know, like for like. So 5 times 10 to the minus 2 minus 0.2 times 10 to the minus 2 is simply 4.8 times 10 to the minus 2. And again, in this example, it's in standard form, so I don't need to make any adjustments. That won't always be the case, perhaps, so just be mindful of that. If it had come out as a number other than something between 1 and 10, again, you'd need to modify the answer. That's it really. Now the majority, you know, the overwhelming majority of questions that you're going to be asked on standard form basically involve these skills: changing an ordinary number to standard form or a standard form number to an ordinary number, adding or subtracting standard form, multiplying and dividing standard form. You may very well get a question in context. But again, in the overwhelming majority of cases, what else can it be other than adding or subtracting standard form or multiplying or dividing standard form? So always look at the question from that approach. So certainly we've looked at questions where you're finding the distance between you know, two objects where they've been described in standard form. Well, it's going to be a, you know, a subtraction, or, you know, depending on the question, maybe an addition. Again, addition and subtraction are more difficult, so you know, the way the exam's going, maybe that's the sort of question that they're going to be asking. And again, the examiner, they can be you know, quite inventive and come up with questions that we haven't seen before, but it's important that you are good on these set of skills described in this video.